If your chat app waits for the full completion before showing anything, users stare at a spinner for 5, 10, sometimes 30 seconds. Streaming fixes the perceived latency by pushing each token as the model generates it. In this video, we go deep on streaming Azure OpenAI responses token by token in Python. We'll cover what's actually happening on the wire, the exact code that turns it on, how to parse the delta chunks, how to wire it into an async web server, and the production gotchas that bite people. Let's get into the mechanism. Under the hood, streaming is just server-sent events, SSE, over a single long-lived HTTP response. When you set stream to true, Azure OpenAI keeps the connection open and writes a sequence of lines, each prefixed with data : containing a JSON chunk. Every chunk carries an incremental piece of the message in a delta field. The stream ends with a literal data : DONE marker. The Python SDK hides this framing from you and hands back an iterator of typed chunk objects. But knowing its SSE explains the proxy, buffering, and timeout behavior we'll hit later. Here's the minimal synchronous version. You create an Azure OpenAI client with your endpoint, API key or token credential, and an API version. You call chat completions create with stream equals true, which returns a generator instead of a single response. You iterate it, and each chunk has a choices list. Critically, the first chunk often has an empty delta, and any chunk can have content of none when it's carrying a roll or finish signal instead of text. So always guard with a none check before you print or yield. Otherwise, you'll concatenate the string none into your output. Each chunk is a partial chat completion. The delta only contains what changed. The first delta usually sets the role to assistant. The middle deltas carry content fragments which are often subword tokens, not whole words. And the final chunk sets finish unscreasen to stop, length, or content_filter and carries empty content. If you want usage token counts while streaming, you must opt in by passing stream_options with include unusage true, which adds one final chunk containing the usage object. Without that flag, streamed responses give you no token accounting at all, which surprises a lot of people building cost dashboards. In a real service, you want async so one worker can handle many concurrent streams. Use async Azure OpenAI and async for over the stream. Then re-emit it to the browser as your own SSE response. With FastAPI, that's a streaming response over an async generator yielding each fragment. The key architectural point: you're terminating one upstream SSE stream from Azure OpenAI and producing a fresh downstream SSE stream to the client. So backpressure and client disconnects propagate. Handle essential CancelledError to stop pulling tokens, and close the upstream stream when the browser tab goes away, otherwise you keep paying for generation nobody reads. 3 things bite people. First, buffering proxies. Nginx, Azure Front Door, and some gateways buffer responses by default, which collects your whole stream and defeats the point. Disable proxy buffering and set the content type to text event stream. Second, timeouts. A long generation can exceed default idle timeouts on load balancers and the SDK client, so raise them deliberately. Third, content filtering. Azure applies content filters to streamed output too, and a flagged span can terminate the stream mid-sentence with a content_filter finish reason. So your client code must handle a stream that stops early. Always check finish and reason rather than assuming clean completion. Streaming isn't always the right call. For interactive chat it's clearly worth it. The user sees motion immediately. But for backend pipelines where you parse the whole answer, for structured outputs you validate as JSON, or for tool calling flows where you need the complete arguments before acting, a plain non-streaming call is simpler and less error-prone. You can stream tool calls, but you have to reassemble fragmented argument strings yourself, and that's a common source of bugs. Pick streaming for human eyes, blocking for machine consumers. To recap, Streaming is SSE over one connection. You enable it with stream equals true. You guard every delta against none content. And you go async with async Azure OpenAI to scale concurrent streams. Watch the production gotchas, buffering proxies, timeouts, and early content filter termination. And reach for include_usage when you need token counts. Your one concrete takeaway: wrap your stream loop so it always inspects finish_reason and propagates client disconnects, so you never silently truncate output or pay for tokens nobody reads. API versions and filter behavior change, so confirm the current values in the Azure OpenAI docs before you ship. Build something, and I'll see you in the next one. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.